Hi there, 6Bs. All right, as promised, I am trying out some new technology here, and we are learning now about data management. So let's do it. Today, I'm going to talk about the different types of graphs and how we can make inferences from graphs. So let's start out with a bar graph, and maybe you can follow my mouse here and just follow along with me. Bar graphs are used just to compare facts, and bar graphs are great because we can see easily which group is most represented and which group is least represented. They can be difficult to read accurately, but a change in the scale can confuse your understanding of the data. So even though there are some drawbacks of bar graphs, there's a lot of great things. And the great thing is that we can just read it really quickly and we can really see the differences. So let's take a look at this bar graph here. This bar graph is about sneakers sold this month. And maybe this data was taken from a little sports shop, maybe in Mongkok. So let's take a look at it. The first thing that you can see is that there's a clear title here, and there's labels down the side. These are types of sneakers, and at the bottom, number, how many pairs of sneakers. So when I look at this, can you see right away which type of sneaker was the most popular at this little shop in Mongkok? Yep, you're right. Maybe, I don't know, I'm assuming you're right. It's Nike. They sold 32 pairs of Nike sneakers. And you can see on this bar graph that whoever made this bar graph decided to write at the end of the bar exactly how many sneakers there were that were sold. And you can see it right there. And if you lined up that line with the bottom scale, you could see, yep, 32 pairs. And I can also see that there was a pair of sneakers that were about half as popular as Nike. Can you tell which ones were half as popular as Nike? About half? Yep, you got it, I hope. It's Reebok. They sold about half the amount of Reebok sneakers as Nike sneakers. And we can see that this bar is about twice the size of this one. Note that I'm saying about, not exactly. So if I had to make an inference from this bar graph, I could infer that next month Nike sneakers will also be the most popular. So an inference is just making a guess, but it's according to information that I have. So there we go. There's our first bar graph. And that bar graph is just showing us some facts, some information. Now, let's look at another bar graph here. Again, you can see that this bar graph has a title, scores by team per season. So maybe this is a professional soccer team, and the managers of the team are trying to figure out how many how many goals they've scored. And there's a scale here, and there's labels, points and season. So in this graph, there is not just one line per season, there are three. So there's a key, K-E-Y, there's a key right up here. Team A is red, B is green, C is purple. Oh, sorry, that's blue. Team B is blue. So I'm wondering if you can see which team had the worst scoring in the season 2002. So, yep, pretty easy to see. 5 points. Team A only scored 5 points in 2002. And the best showing of all the seasons, can you tell what that would be? Yep, it's the blue team. Team B, 82 points in 2002. Wow, they must have been a really great team. And you can see again in this bar graph, on the top of each bar, they've written how many points exactly, because if you followed along to the scale at the side, you might not be able to tell exactly how many points. So whoever has made this graph has decided to write the values here. So there's two bar graphs, and the first one we looked at, sneakers sold in a month, it's a little bit less complicated than this one, but hopefully you can follow. All right, next we're looking at a circle graph. Here we are. So circle graphs, they're used to compare parts of a whole. So circle graphs can be a little bit tough to do without a computer, but and they're also good to do when we have fewer sections. And each value needs to be different in order to see the differences. So here's a great circle graph, and this is composition of the Earth's atmosphere. Atmosphere, that's just the air that we're breathing right now. So we can easily see that there's a title and there are labels. And we can see that this purple part here makes up a big part of the circle, and that's nitrogen. It says it right here, and nitrogen makes up 77% of our atmosphere. So this whole circle represents everything in our atmosphere. That's the whole. Part of a whole, nitrogen, 77%. The next biggest section, oxygen. Oxygen represents 21% of our atmosphere. And lastly, there's some other stuff in there. Other, 2%. So that's our atmosphere. This is 100% of our atmosphere, and these are the different sections of the circle graph. So, circle graph, parts of a whole. Lastly, we're moving on to line graphs. Line graphs are used to display data or information that changes over time. Time is the important word here for line graphs. Line graphs represent changes over time. That's important for us to know. And line graphs allow us to see overall trends, such as an increase or a decrease in data over time. So let's take a look at this example here. This line graph is showing us humidity levels in a small town in New York. So we have high humidity in Hong Kong. All of us know about humidity. So down the side, we have a label. This is the humidity. And this side, the label day. So on day 1, the humidity was right here, 51% humidity. And again, they've written the number there so that we don't have to guess 51%. Although that one would have been pretty easy to guess that it's 51. Anyway, and then on day 2, we can see that the humidity was 59%. On day 3, 65%. Day 4, 68. Day 5, 70%. You can see 70 exactly. Day 6 was 67%. And day 7 was 72%. Now, a line graph is great because we can make some pretty good inferences from this. The first thing that we can see is that generally the humidity is increasing. So the trend is that the humidity is increasing in this small town. Even though one day the humidity went down a little bit, the general trend is that the humidity level is increasing. So if I was going to make an inference from this line graph, I could say that the humidity level is increasing. And I can also guess that on day 8, maybe the humidity is going to be 73, maybe 74%. So that's a line graph, and we need to remember that line graphs show changes over time. All right, let's go to our book here. So here is our book. Let me make this a little bit bigger. 100%. There we go. And whoops, I want to look at this question at the bottom here, the practice question. So this question says, use the circle graph to answer these questions. And this is the circle graph. And the circle graph, the title is Population of Atlantic Provinces. This is in Canada in 2001. Woo, long time ago. Maybe that's when you guys were born. All right. So if you look at this circle graph, and you can remember that a circle graph is used to show parts of a whole. You got it. All right. So this is representing the whole population of the Atlantic provinces. Question A says, which province made up about 1/3 of the population? So if you look at this circle graph, hopefully you can see the answer to that. Part B says, which province has a population almost twice as great as that of Newfoundland and Labrador? Well, Newfoundland and Labrador is this little yellow part. So which one, PEI, Nova Scotia, or New Brunswick? PEI, NS, NB. Which one is about twice as big as Newfoundland? And how does the circle graph help you to find this quickly? So how can you see that quickly? All right, that's question number 1. Can you pause me right now and give question number 1 a try? Answer 1A and 1B. So pause now, give it a try. All right, I hope you paused it, and I hope you got that question. Let's look at question number 2 now. It says, which graphs show the same information? How do you know? So there's 3 graphs here. This one, circle graph, we know that one. This one is a bar graph, we learned about that. This one is a pictograph. It's quite similar to a line graph. And it's pretty easy to understand. So if you look at graph A, graph B, and graph C, 2 of these are showing the exact same information. Can you figure out which 2? Oh, maybe all of them are. Who knows? It's up to you to figure it out. But you can see here, graph B is the bar graph. Walking, 4 students walk. Okay, so 4 students walk, and over here, walking, 1, 2, 3, 4. So far we know these 2 are the same. So which of these graphs are showing the same data? Can you pause me now and give that one a try? So you finished number 1, now you're doing number 2. So pause. Okay, hope you had a good time doing number 2, everybody. So let's give number 3 a try. Number 3 has a line graph, and we can remember that a line graph shows us changes over time. And the question says, what can you infer from this graph? So check it out. They're talking about population growth in a town. Down the side, there's a label, population in thousands, and then year. So in 1930, there were 5, but this is in thousands, so there were 5,000 people. In 1940, oh, maybe that's a 6,000 people. 1940, 5,000. 1950, maybe 6 or 7,000. 1960, whoop, that's about what? Maybe 21, maybe 22,000. And you can go on and read this, and I want you to make an inference from this graph. And the inference I want you to make is, I want you to tell me if there is an upward trend or a downward trend. So what that means is the population growing, or is the population shrinking? And I also want you to guess, just take a guess at what could the population be in 2010, even though it's not on the graph. I want you to infer from this information what might the population be in 2010 if the graph is going to, if the population follows the same trend. So give number 3 a try now. Can you pause me here and give number 3 a try? Okay, I hope number 3 went well, and we'll go over those 3 questions in class tomorrow. and I hope you had a fun time learning online. All right, everybody, have a good night, and I'll see you tomorrow.